Hey, I'm thrilled about diving into file handling with Python because it's such a core skill for IT work and beyond. Let's get straight to it and start by understanding files. They're quite simple, just bits of data stored permanently outside of RAM, right? Now, imagine files as a recipe book. You've got the text files, with plain content, images, audio files, and so on. I love text files because they're versatile and crucial for data analysis, like when you need to analyze feedback or parse logs. Python sees text files as nothing more than plain old bytes to be read and written. Starting our journey with opening a file is straightforward. You use the open function with the file name and mode. It's essential to know your mode: R for read, W for write, A for append, and R plus to read and write. Got it? I remember when I had to output report results to a text file for a project and the W mode allowed me to create it fresh, but I wanted to append data to an existing one later on, and A came in handy then. Once opened, the file's data comes streamed through the cursor, much like navigating a stream with a paddle. Then we got to read, readline, and readlines, tools to read and fetch chunks of data, lines even. Reading text files line by line is a classic, especially when parsing logs or reading configuration files that could be quite lengthy. Now on to write and append, essential for creating content or adding to pre-existing files. Writing requires a fresh file or overwrites if existing. Appending adds without interruption to the end of the file. Python's context managers handle these resources cleanly with the with statement to ensure files are closed, even if errors pop up. Like when you are collecting survey data as we process responses for analysis, making sure each response is appended without mixing them up. Next, we've got to handle exceptions with try-except to manage those pesky IO exceptions, files that might not exist or permissions issues, and you never want your application to crash just because the data you were after was playing hide-and-seek. Closing a file is more about good hygiene than survival. Always close files after you are done, especially on shared systems. It's a mark of courtesy since it frees up resources, similar to turning off a machine after use to not wear it out. Deleting files in Python uses the OS module os.remove, and it's like retitling our book as we get rid of chapters we are no longer needing for a project, say after a presentation. But here's where it gets spicy: reading binary files, like images, or writing them. Images need special handling, the B magic in the modes for read-write binary. These are the details of opening files in binary mode, which means dealing with bytes instead of strings without the usual encoding and decoding shuffle. It's a different beast. To manage files effectively, Python's OS and Shuttle modules have libraries, making file operations like renaming, creating directories, copying, and removing simpler and tidier, sort of like using a utility belt with everything you need for fixing up the system or organizing files in a way the data dictates. Sure, reading and writing files can be complex, especially when dealing with multi-line content, new line characters, and file pointers, but that's where control flows and buffering techniques come in, saving our bacon when trying to minimize disk I/O. Just like planning an IT operation where timing and resource allocation matter, reading and writing in chunks and managing buffers can significantly enhance performance. Let's not forget encoding and decoding, because Python strings are just bytes, and converting them into human-readable characters requires this bit of magic, whether we are reading plain text or files in different encodings like UTF-8, which is like the lingua franca for international text data we often encounter. And when we dive into directories, OS directory scanning with walking algorithms reveals files we can work with. It's an organized dive into your file system. Hierarchy, sort of akin to navigating network directories for deploying applications. In this digital age of big data, efficient file handling is a cornerstone of IT, as managing gigabytes of data and ensuring its integrity and security becomes part of the routine. In conclusion, Python's standard library makes handling file I/O pretty smooth, and when you wield these tools with skill, like a maestro of data, you are equipped to handle diverse file-related tasks in your IT career journey. Now, I invite you to visit neeraj.qzz.io and subscribe to TechLab for even more explorations into the fantastic world of Python and IT.